Hello everyone, in this tutorial I'm going to teach you and compare two ways of solving OpenFOAM problems at the same time. One of them is the conventional way of solving the OpenFOAM problems and understand the physics behind all those tools that we have in OpenFOAM. And the second one is the new way of solving the OpenFOAM problems and understand the physics, which is use the source codes of the OpenFOAM and AI together. So I used to solve my problems the um, conventional way, but nowadays I'm using source codes and Chat GBT together to understand how all those tools are working together, and I can understand the physics behind them better. So let's go to the OpenFOAM. In previous video, I taught you how to find OpenFOAM source codes and what each file means. But in this video, I'm not gonna focus on that part, and you can find the link of the video on the description. And it will be just focusing on the source codes and how we can use AI to solve our problems. Let's first focus on the conventional way of solving the OpenFOAM problems. If I go to tutorials, for example, the problem that nowadays I have. I'm working on the multi-phase Eulerian and the boiling bed. We can copy and paste this in the desktop so we don't change the real tutorials. So this tutorial is a multi-phase that we can do the phase change and mass transfer, heat transfer, and everything at the same time. So we need a heat transfer. If you go to the constant and find a heat transfer file, this is a heat transfer between the phases that we have in this tutorial. We have a phase like gas, then we have a liquid, we have a solid, and we have a liquid. We have three phases. It could be four, doesn't matter. Just we have four phases, and for each of these phases between gas and liquid or liquid and gas, we have different heat transfer model. Like for example, gas inside liquid in the gas. So we have a spherical heat transfer model, but we don't know how this model works. So how we can understand what does it mean and what kind of other alternatives we have. If you want to understand and know what other alternatives we have for spherical, I mean, one of them is just you can read other models here. One of them is Rance Marshall, and the other one is Boone. I'm not sure if I'm pronouncing it correctly. Okay, let's pronounce it Gone, for example, here. And there are, of course, some other models that you cannot see here, but how we can find it, you can watch another video that I use the banana trick to find other models. But let's see how we can understand how spherical and Rance Marshall. Okay, the first one is Goon. For example, let's go to this Goon. So we don't know what does it mean. Control C. We go to the we can write Goon heat transfer model OpenFOAM. This is the conventional way. And if you go there, you can find the OpenFOAM Foundation, and you can read everything about this heat transfer model, and you can see other transfer models here. Constant new heat transfer, non-spherical heat transfer. So that's it. You can read this, and I think you won't understand what is going on here because it is a bit complicated for the people who don't know the source codes, who don't know very well how is it going, how the source codes are working. So it's not a good way to understand the models of the OpenFOAM. This was the conventional way. I used to read all these files, but I might understand it and I might not understand. So what I do now, I just use ChatGPT. So how we can use ChatGPT to understand this file. So I want to know the GOON, how the GOON heat transfer model works. So what should I do? I should go to the source codes of the GOON and go to the home, not the home. This is the way that we can find the source codes. It is in Ubuntu. You go to the OPT, then OpenFOAM 13, the sources or the libraries and applications, other solvers. And I know that this heat transfer model is in the uh, solvers because I have used already. And you can find another video that I taught you how to the free powered tools to find every model of the OpenFOAM is the use of grepr. If I go to multiphase Euler, these are the files and phase system, interfacial models, and heat transfer models. And if I come here, I will see all the available uh, heat transfer models, and GOON is one of them. If you go there and if you open the C file, just copy this and paste it in ChatGPT. The .c is the compiler file, so it is the main file of the GOON, and in each file, .c is the main file, and the .h is the header file that we only define our parameters or some other member function, but it's not the main part. But it is very useful because we use some including. I'm not just gonna focus on that, but it's better to give the both files to the ChatGPT to give you a bit better explanation. So I will tell ChatGPT explain this file in details. So this is implementation of the GON heat transfer in OpenFOAM, and it is used in Euler method to calculate the interface heat transfer coefficient H between the dispersed phase bubbles and the continuous phase. So it is a heat transfer between a bubble and a continuous, like if we have a bubble, like the bubbles that when we have a boiling, we have some bubbles in the liquid, so it can model the heat transfer between that model and the liquid. Purpose is just the calculation of the heat transfer coefficient. Sometimes we call it H. Here it's been written K. Doesn't matter. We have a continuous phase, we have a dispersed phase, and it will explain it one by one, all the codes. So now it explains you what each line of this OpenFOAM this source code mean. And this is the final equation that this heat transfer model uses to calculate the heat transfer coefficient. The return coefficient is blah blah blah. This comes from this. And then H, and then so this is the way that you can use to understand and solve your problem. So if you think that this heat transfer model is useful for you, you can use it, or if you think that it's not very useful for you, you can go with other heat transfer model. So this is the way that I use nowadays to understand the physics and source codes at the same time, and it will be very useful for you to use the new things like ChatGPT that we have nowadays to solve and understand the problems and physics behind the source codes. And see you in the next video.